the new Fronius Smartmätare TS. Good afternoon, everyone, and welcome to our Fronius webinar today. I just hope that you can hear me in the beginning. Just please give me a feedback if you all hear me. Yes, I think I received some feedback that you are hearing me. Perfect. My name is Nima Badri. I'm working as technical advisor at the business unit Solar Energy at Fronius, Sweden. I will be holding the webinar today, but at the other end of the line, we have our colleague William Petson, who works also as technical advisor at the business unit Solar Energy, Fronius. I'm still a bit unsure if you all can hear me. Just please raise your hand if you can hear me. Oh, great. Yes, thank you. Thank you all. Yeah, then we continue. For those of you who might already know us, both me and William, nothing new here, but we have a special guest today, Hans Pelzer from the team Training and Education from the business unit Solar Energy at Fronius International, from our headquarters all the way from Austria. And that's the reason why we are holding the webinar in English today, if you wonder why. So if you have any questions, just please feel free to ask your question in the chat during or after the webinar. And we will be, my colleagues William and Hans will be taking care of your questions, of course, during and after the webinar. Yes, just moving forward with the agenda for today. We are going, of course, to talk about the Fronius Smartmätare TS today. The TS stands for touch screen, as we can clearly see from the display of the smart meter in the picture. It's a touch screen display, and we are going to gradually replace the old smart meters with these new smart meters, the TS models. But it doesn't mean that we are going to replace them over a day. Rather than that, we are going to, as mentioned, to gradually replace them. So if you're still using our old smart models, smart meter models, so you just continue using them, installing them, no problem there. But as mentioned, we are going to gradually replace them with the new models. So in this webinar, we are going to have focus on the technical data of the new smart meters. That's actually compared to the old models, they are actually exactly the same functionality, the same functionality, same information we are sending to the still again, someone's asking if we are because I asked in the beginning that we are you are hearing me, so I got the hands on, but I think my colleague William has some problem with the voice. He can't hear. Just give me a few seconds here so I can give him a feedback that everyone can hear. Yes, sorry. So we are talking about technical data here. So exactly the same data we are having from this smart meter on the Solar.Web. We have the same functionality, but when it comes to installation and commissioning and configuration of the smart meter, the new smart meter, then there are some differences that we are going to go into the details during this webinar. We are then going to, we had previously 2 webinars before. The first webinar was basic information about the smart meter in general. Then we had a second webinar regarding the installation, commissioning, and configuration of the old models. And here we are having the focus on the installation, commissioning, and configuration of the new models. Then we continue with the energy profiling and visualization. Energy profiling means that we are using more than one smart meter in a system in the installation. So if we have a secondary smart meter or even additional more smart meters in the system. So if we have the primary smart meter in the feeding point of the PV system, for example, and then we have an additional smart meter if we have specific loads that we want to know the specific consumption of those specific loads, then we add an additional smart meter in the consumption path of those specific loads. For example, if you have a heat pump or if you have an air conditioning or EV electric vehicles, then you can know the exact consumption of those specific loads. Then we continue with the installation of the smart meters, the correct cabling when it comes to the cabling of the smart meters to the data communication card of the inverter. Then after the installation, we need to do the commissioning of the smart meter, of course, either on the our old snap inverter models or our Gen 24 hybrid inverters. So the commissioning is a bit different here, which we are going to go into the details. After that, we continue with the configuration on the smart meter display itself. So when we've done the commissioning, there are some configuration needs to be done on the display of the smart meter itself, depending on the number of the smart meters we are using in the system, and also depending on the type of the smart meter. But more into that coming into the next slide. And last but not least, we are going to talk about dynamic feed-in limitation. That's the additional setting we can do having the smart meter in a PV system installation. Yes, so moving to the next slide, the smart meter itself, as you know, it's a bidirectional meter which measures the energy, the whole energy flow in the household. So it's measuring the it's measuring the consumption and production in the household, how much energy we are producing in the household from our PV system, and how much energy we are, how much surplus energy we have from the produced power in the household, and how much energy we are buying from the grid. So that's the whole energy flow in the system together with this smart meter we can have in the together with the smart meter, we can have the data sent to our Solar.Web, our online monitoring tool. And there we can do all the detailed analysis and visualization of the whole consumption. So when it comes to the type of the smart meters, we've got 3 different types of the new smart meters. The first one, the 100 amps for a single phase network for residential systems. The 80 cable cross section here is up to 16 square millimeters. Then we have the second smart meter, the one in the middle, which is for a 3-phase network, also for residential installation, 65 amps. The 80 cable cross section here is also up to 16 square millimeters. Then the third the smart meter, which is for commercial installation, the smart meter 5 kiloamps is also available for commercial users as mentioned for 3-phase network. Here the 80 cable cross section is up to 4 millimeter square millimeter as mentioned, because here we're just measuring the voltage. And as we can see in the picture, we have those 3 external current transformers also. So every time we are using this commercial smart meter, we need to install those current transformers also. But we are going to go more into detail of those current transformers in the coming slide. Moving forward, there are 3 different ways of installing in a smart meter in a PV system. So the first option is to install it in the feeding point of the system, which is the recommended position. Normally recommended to position it in the feeding point. It's not mandatory, but as said, it's recommended. But if we have a battery in the system, for example, if we have a backup system in the system, then it's mandatory to have the smart meter in the feeding point, of course. Then we know the exact surplus energy being fed to the grid together with the smart meter and the communication of the smart meter to the inverter. Then the inverter knows that that surplus energy can be charged to the battery instead. The second option is to install the smart meter in the consumption path of the load. So, but as said, that's more recommended to put in the feeding point, but it is also possible to put it in the consumption path of the load. Then we have the third alternative, when we have the energy profiling. And we have more than one smart meter in a system. So we have the primary smart meter in the feeding point. Then we have a secondary smart meter in the consumption path of the specific load. So here we have a complete PV system with our Gen 24 hybrid inverter connected to a battery. We have even an on pilot for hot water generation. We have the wall box for EV charging. Then we have put the secondary smart meter at the consumption path of the wall box to know the exact consumption of this specific consumer, which is the electric vehicle. So then together with the help of these two smart meters, we have the data sent to our Solar.Web online monitoring tool. This is a screenshot from Solar.Web. So if we, I mean, the colors are different now. We have changed the colors on Solar.Web, but that's the same concept. If you can see here, we have the yellow color here, which is the energy from the battery. Then we have the light purple one in the middle, the energy from the on pilot, and the green, which is the one to the grid, the surplus energy, of course. We have the gray color here also, which is the direct consumed energy in the household, on PV produced directly consumed in the household. Then we have this bar here, which is the consumption of the electric vehicle with the help of this secondary smart meter. But as you can see, the colors are the same. The direct consumption and the measured data from the secondary smart meter, the colors are the same. But if you want to have a closer look, then you go to Solar.Web under analysis and history. And there we have the devices. We can choose two different meters we have in this system, for example. So you choose energy meter for the air conditioning here, for example, and then we have the energy meter for electric stove. And there we can have a more detailed information, have exact consumption of those two different smart meters in different positioning. And could be read daily, monthly, or yearly. Moving forward, when it comes to installation of smart meter in a PV system, of course, safety is always the most important thing. So we got two different protection covers here on this new smart meters. So the first cover is the protection cover, which goes over the connection terminals of the phases. So we have pin 1, 2, 3, and 4, 5, 6. We covered these connection terminals to secure them when you as an installer working on these data communication pins to connect the smart meter to the data communication card of the inverter. Then we have sealable terminal covers, which go over all the connection terminals and secure everything here. For the correct screw torque, we use a maximum 2.8 Newton meter on the measurement output of the first two smart meters, the 100 amps for the single phase and 65 amps for the three-phase network, which means that we are coming to the smart meter from the grid to the pin 1, 2, 3, and we are going from the pin 4, 5, 6 to our loads. And on these connection terminals, we use 2.89 Newton meter. Then when it comes to our commercial smart meter, the 5 kiloamps for the three-phase network, we use the maximum of 0.6 Newton meter. And for the data output, we use 0.4 Newton meter. When it comes to the connection of the cabling of the smart meter 65 amp to the inverter, to the data communication card of our new inverter, the Gen 24 hybrid inverter, the pilot. So as you can see here, as mentioned, we are coming from the grid on the top, pin 1, 2, 3, and we are going to our loads, pin 4, 5, 6. Then we have a pin above this display for the neutral connection here. And as we can see, we have a fusing here as well, a minimum fusing of 350 milliamps. This is not required in all the countries, but depending on which country the installation is, so the fusing could be required by that country. On the other side, on the pilot or data communication card of the inverter, as we can see, there are those orange terminal plugs, and on those terminal plugs, we can see our Modbus RTU addressing. And this is the advantage with the new inverter, new Gen 24 inverters, that we have two Modbus connection area. So if you have more than one smart meter in the system, if you have, for example, a battery or an on pilot in the system, you can connect them both on the same terminal. The connection itself to the data communication card, it's simple. It's like our old snap inverters. So that's just data minus, data plus, and the ground. Just the naming which is different. It's M0 minus, M0 plus, and the ground, but that's the same naming as it was in the snap inverters. That's the same positioning. So we go from the pin number 8 to the data plus, from the pin number 9 to data minus, and we go from pin number 10 to the ground. And after that, we use a shielded cable here for data plus, data minus, and the ground, and we ground the shield in this specified pin here. One other important thing, because it's a serial Modbus connection, so we need to terminate the loop at the end of the loop, at both ends of the loop. So on the smart meter itself, the termination 120 ohm resistor is already integrated. The only thing you need to do is to do a bridging between the pin number 7 and 9 here. And this way you have activated the termination, the 120 ohm termination. And the data communication card of the inverter, you see this tiny little switch here. You just switch it and to the position 1, and that way you have activated the termination. One other important thing when it comes to the installation, which is not listed here, is that we use a twisted pair cable between data minus and data plus. Again, installation of the same smart meter, this time to snap inverter, to data manager, not the new Gen 24. So of course, the installation on the smart meter side is exactly the same. But when it comes to the connection to the data manager, here, as we can see, as mentioned, we have the naming data D minus, D plus, and minus for the ground. So again, from pin 8, we go to D plus, pin 9 to D minus, and we have the ground to minus the ground. And again, we use a shielded cable here, and we ground the shield. And also, of course, the termination here and the smart meter, the same. And on the data manager card is that little switch next to the Wi-Fi antenna there. When it comes to our third smart meter, the smart meter 5 kiloamps for commercial installation, the installation of that smart meter and cabling to the Gen 24 data communication card. As you can see, there is some differences here because we needed those external current sensors. As we can see, they're coming from the top, going to each phase, going inside the smart meter. Again, termination on the smart meter between pin 7 and 9, we do the bridging, and we position that to the position 1 to do the termination also on the pilot or data communication card. Also, something we need to keep in mind is that for this type of smart meter, we need an external power supply underneath here. So we can see the phase and neutral. It could be also a DC power source of power, but since we are talking about the placing of the smart meter in the main distribution panel, then it must be available phase and neutral anyway. Again, here we have fusing of minimum of 350 milliamps, not mandatory again, if required by that country. We have, again, the same connection when it comes to the connection point to that data communication card. So no differences here, of course, that's the same. So just to sum it up, the most important thing we mentioned during the installation, we mentioned that we used the twisted pair cable between D- and D+, and for that, the Cat5 or high class is recommended. Then we talked about the protection covers to cover the connection terminals of the smart meter to protect you as an installer when you're working on the data communication pins. We talked about the termination. So you activate the termination on the smart meter by doing that bridging between pin 7 and 9 and that tiny little switch on the data communication card. And we use a shielded cable, and we ground the cable, shielded cable between D-, D+ and minus the ground. All right, that was about installing smart meters, different types of smart meters. But now we are done with the installation. So after the installation, we need to do the commissioning of the smart meter. And how we do it? We need to do the commissioning. We need to tell the inverter that there is or there are smart meters in the system. And how we do it? On the Gen 24 models, because we don't have any display on the inverter, so we simply click on the button on the front side of the inverter, and this way we activate the Wi-Fi access point. Then you go to the Wi-Fi setting of your device, and you choose Fronius network. You enter the password. That's the standard password for all of our inverters from 1 to 8. And after that, if you're using your computer, you go into your browser and you enter this IP address. And after that, you getting into the web interface of the Gen 24 inverter. If you're using the app, if you're using the Solar Start app, after activating the Wi-Fi access point, you will be automatically redirected to the web interface of the inverter. So after that, once in the web interface of the inverter, under the device configuration and the components, you can just simply add smart meter here. So you find smart meter, Fronius smart meter, and the positioning of the smart meter here. In this case, is feeding point, and you just add it. Modbus address 1, you just add it. If you have a secondary smart meter, you do the same way for the second smart meter. You save it and you process. Regarding the snap inverters, for being able to get inside the web interface, of course, you activate the Wi-Fi access point via the display of the inverter. Then you enter the same IP address as I mentioned to get into this web interface of the inverter. And once in the web interface, under the settings and the sub-menu meter, there you can add the primary smart meter. So you add the front smart meter here, then you receive this box, the messages in the box, then you choose the positioning of the smart meter, of course. You can choose either in the consumption path or the feeding point. In this case, is the feeding point. And after that, you receive the state code message in blue, OK, which means that the inverter has found the smart meter. Everything's good to go. Then you just click OK and you process. Of course, if you have a secondary smart meter, then you do the same settings here as well. Now, after the installation and commissioning, there are still some configuration needs to be done depending on the number of the smart meters you are using in a PV system. So if you have just one smart meter in the system, you don't need to do any configuration at all. But as soon as you have more than one smart meter, then you need to do this configuration on the smart meter via the display of the smart meter. Because when we deliver the smart meters as standard, all the smart meters have the Modbus addressing of 001. But as soon as you have the secondary smart meter, then you need to change this Modbus addressing. And how you do it? Via the display of the smart meter, you press enter for 2 seconds. We have the guideline here, the enter button in the middle. You press it for 2 seconds. Then you choose page 1 with these up and down arrows. And after that, you enter the password 2633. That's the also standard password for all of the smart meters. And after that, you again choose page 14 and you press enter for 2 seconds again. And there you need to change the Modbus addressing from 001 to 002, for example, if it's your secondary smart meter. After that, you change it again to page 18 with these up and down arrows. And you press enter again for 2 seconds, and you are done with this configuration. Another thing is, which is important to keep in mind, is if you are using the commercial smart meter, the smart meter 5 kiloamps, there you need also to do the configuration for the ratio for the current transformers, because there are lots of different current transformers available in the market with different ratio, so you need to set the correct ratio. The correct the current sensor with factor from primary to secondary here, for example, from 50 amps to the secondary 5 amps, we have a factor of 10, which needs to be set within the display of the smart meter. But of course, always different depending on your choice of current transformers. But normally the factor is printed on the side of these current transformers. And how you do it, again, you press enter for 2 seconds. You select page 1 here. You enter the same password again. Then you select page 4. And after that, you press enter for 2 seconds. And here you need to enter this factor, which is the factor of 10 in this example. After that, again, you go to page 18 and you press enter for 2 seconds, and you are done with this configuration. We have a guide, we have a table here for the selection criteria of the correct current sensors. So when you are choosing the current transformers, 2 things you need to keep in mind. The first thing is important is the own consumption of this commercial smart meter, the 5 kiloamp smart meter, is about 0.5 volt ampere. The second thing we need to keep in mind is the length and the cross section of the cable between the smart meter and the current transformers. So the power of the current transformer must be higher than the sum of the power of the Fronius smart meter, which is 0.5, and the line resistance of these cables. For example, if you have a cable between smart meter and current transformers, the cable thickness, we have the cross section of 2.5 square millimeters and the length of 5 meters, for example. Then we have a line resistance of 1.8 volt ampere. So this value added to this value should be the minimum required when choosing the correct current transformer. Of course, this is the minimum required, but the higher is the better. So this is how we choose the correct current transformers when installing that commercial Fronius smart meter. All right, there is some additional settings also on the web interface of the inverter when we have smart meter installed, and that's the dynamic feeding limitation. So you can just simply limit your feeding amount to the grid. And how you do it, again, once you're connected to the Wi-Fi of the inverter, you go to the web interface of the inverter. In this case, this is the Snap inverter. Then under the settings, under the sub-menu DNO editor, then you have the dynamic power reduction, for example. And here you choose limit for the entire system. So if we have a closer look on that, here you enter the total power of your PV system, in this case, which is 7.5 kilowatt. And then you can enter the production power of the entire system. That's either in power range or in percentage. So you can decide how you want to limit. I know there are some regulations in different countries. I know in Germany, for example, you are not allowed to feed in more than 70% of the total power of your PV system. And that way you can just limit. Or even here in Sweden, you want to limit how much you want to feed into the grid. That's the way you do it. Of course, always after every changes in the web interface, you need to save the changes before you process. Important. Then we have the same thing when it comes to Gen 24, how you do the limitation on the Gen 24 inverter. You activate the Wi-Fi access point once in the web interface with the Solar Start app. In this case, under the settings, you have the same functionality here again, dynamic power reduction. So you activate it, you enter the total power of the system and maximum grid feeding power. Then you click next and you are done with this configuration. Those two. All right, this is the last slide I have here before I finish the webinar today. Of course, with the help of smart meter in a system, we can have a better understanding of the whole energy flow in the system in a household. And after about a year, you as an installer or you as an end customer, you always have the possibility to do the simulation. We have these two different simulations integrated in our Solar.Web, our online monitoring tool. So together with the help of these two simulation tools, you can advise your customers how they can be better, how they can increase their own consumption. After a year, if you see from the data from the Solar.Web how much surplus energy they've been feeding to the grid, so instead of feeding all that surplus energy to the grid, you can advise them to, for example, to increase their own consumption by adding a battery to make a system, to complete their system and retrofit the system and increase the self-consumption up to 82%. On the other hand, if you want to add on pilot, for example, to the system, you still do the same simulation with this simulation tool for the on pilot to produce hot water. And by that simulation, you can see that you can increase, in this case, for example, you can increase your own consumption to up to 45%. Yeah, that was all from my side. If you need any further information when it comes to our new smart meters, the installation, the commissioning, the configuration on the smart meter, so you just go to our homepage and you simply search for Smartmätare TS, or you go to our installer support area in our homepage and you find everything, all the related materials there. Or you go to our YouTube channel on YouTube and you find all our webinars listed on YouTube in different languages. Of course, we got our own channel in Swedish and we got all our webinars in Swedish. In this specific webinar, we had it in English because we had a guest speaker from Austria, who is in the chat. And from the next webinar, we continue with our Swedish webinars, of course. Thank you. That was all from my side, and I wish you all a very nice week.